Today I'd like to review the metric system. It's important when scientists go into lab that we all use the exact same unit of measurement. That makes communication very clear and easy across the entire scientific community throughout the world. For example, what I mean by that is if I go back to lab and I measure volume in ounces, a scientist in Germany measures that same volume in milliliters, we're going to have difficulty communicating and understanding each other's data. So the scientific community has decided that throughout the entire world, we are all scientists going to use the metric system. So we have decided that we are all going to use specific units, and that way we don't have to convert numbers in units. When we communicate data and share lab results with each other, we're all using the exact same units. So the metric system is the standard measurement used by scientists for clear communication when we're discussing lab results and data. Okay? The metric system starts with the first unit that I expect you to know is kilo. That lowercase k right there stands for kilo, K-I-L-O. The next prefix in the metric system that you need to know is hecta, capital H-E-C-T-A. Then deca, spelled capital D-E-K-A. Okay, then your base right here stands for your gram, which we're going to abbreviate with just a lowercase g. Okay, your meter, which we're going to abbreviate with a lowercase m. And your liter, which we're going to abbreviate with a capital L. Your lowercase d right here stands for deci. Lowercase c stands for centi, and lowercase m stands for milli, M-I-L-L-I. Okay? Now, these are the prefixes that I expect you to know for my class. However, I would like to mention that in society, technology over the last 10 years or so has just made leaps and bounds very, very quick. So I would like for you to know you're hearing a lot of prefixes just in common terminology that go above and beyond this. What I mean by that is, okay, I'm going to rewrite these down here just a little closer together. There's your kilo, your hecta, your deca, your base, your deci, your centi, and your milli. Okay, you may have heard of something called a micro, like a microgram. Okay, micro is 3 places past milli. It's symbolized with a little u. Looks to me like a cursive U with a little tail on it. And then 3 places past that, you have a nano. Nanoparticles you may have heard of in research or in the news. I have a former student who is at Clemson right now researching nanoparticles, working with a professor to create these tiny, tiny little particles called nanoparticles that hopefully chemists, doctors will be able to inject into a cancer cell. That nanoparticle is a specific chemical that will hook onto a cell, target just cancer cells, and kill just those specific cells. So if that research proves to be good, then you can avoid the negative side effects of current cancer treatments such as radiation and chemotherapy. My father-in-law unfortunately passed away a couple of years ago from cancer. He had lung cancer and then it turned into brain cancer as well. And the chemotherapy treatment that he went through was just brutal on his body. And the radiation treatment that they used to treat both the lung cancer and the brain cancer damaged other parts of his body as well because of just where those cancer cells were located. It was very difficult for the radiologists to target just the cancer cell, okay? Caused some damage to some parts of his heart because the radiation went, too close to that area when they were trying to target the specific spot on his lung. Okay, so if you've heard of nanoparticles, that's where that comes from. I'd also like to mention on this side of the scale, out 3 places past kilo, you may have heard of mega or giga, 3 places past the mega, or 3 places past giga, tera. So if you ask, any older adult, tera is capitalized with a capital T. If you ask any older adult in your household, they probably remember buying USB drives, flash drives in kilobytes that had kilobyte storage. And then it very quickly transitioned to mega. You've got a lot of storage devices now with gigabytes. And I just bought an SSD card that stores 2 terabytes. So we very, very quickly in a small time span gone past this little bit of information that you have right here and expanded it out. But once again, those are the ones that I expect you, the ones I've circled are the ones that I expect you to know for quizzes and tests. You will work this extra information the exact same way. If you get to college and your professor requires you to know those, you'll do it the exact same way I'm about to show you. Okay? All right. So what I would like for you to do now is make sure you are comfortable converting between units. So let me show you how to do that. For linear measurement in this class, when we're measuring length, we are always going to use a standard of meters. So this right up here, we're going to go back to our King Henry died by drinking chocolate milk, if you remember that from elementary school. The way I want you to do these is I want you to find the unit that's furthest to the left-hand side of your King Henry died by drinking chocolate milk. In this case, for this first example, I see meter and decimeter. So up here, I'm looking at my base because remember my base is my gram and meter and my liter. And I'm looking at my deci. So once again, focus on which of those two is furthest to the left-hand side of your King Henry died by drinking chocolate milk. I want you to put a 1 next to that one. Then I'm going to start on the one that's furthest to the left, and I'm going to move my pencil or finger. In this case, I move 1 place. Since I move 1 place, I'm going to add 1 0. So 1 meter is 10 decimeters. Okay, let's do another couple of examples. Let's look at this one. I've got milli. Okay, that's a millimeter. Right there, that's a milli. Here's my meter. That's my base. Put a 1 next to the unit that is furthest to the left up here on your King Henry died by drinking chocolate milk, the first one you come to as you say that little statement. In this case, it would be meter. So I put a 1 right there. I'm going to move 1, 2, 3 places. Okay, let me show you that one more time. I'm going to move. Some students have just a little difficulty with that. So I'm going to show you, I'm going to move 1, 2, 3 places. And therefore on this one, since I moved 3 places, I'm going to add 3 zeros. So for every 1 meter, there are 1,000 millimeters. Let's do another one. Down here I have kilometer or kilometer and meter. So up here I'm dealing with this one and meter, which is part of my base. The unit that's furthest to the left is the kilo, so I'm going to put a 1 next to that. I'm going to move 1, 2, 3 places. So on this one I'm going to put 3 zeros. Okay, down here I have centimeter and kilometer, kilo and centi. So I'm going to put a 1 next to the kilo because it's furthest to the left. And I'm going to move 1, 2, 3, 4, 5 places. So I need a 1 with 5 zeros. 1, 2, 3, 4, 5. So there are 100,000 centimeters in every 1 kilometer. All right, so let's do a little practice. Instead of length, let's do mass. So I'm going to sketch my King Henry died by drinking chocolate milk right here. Gram would be part of my base. Kilo, kilogram, kilo is right over here. Kilo is furthest to the left, so I put a 1. I move 1, 2, 3 places, and therefore I put 1, 2, 3 zeros. So there are 1,000 grams in every 1 kilogram. Okay. Milli and gram. So my King Henry died by drinking chocolate milk. The milli is right here. The gram is part of my base. So I'll move 1, 2, 3 places. I put a 1 next to gram because it's furthest to the left. And I move 3 places, so I put 3 zeros on the milli. There are 1,000 milligrams in every 1 gram. Okay, one last one. So for this one, I've got kilo and deci. King Henry died by drinking chocolate milk. I've got my kilo and my lowercase d, my deci. Kilo is furthest to the left, so I put a 1 next to that. And I'm going to move 1. Oops, sorry guys, I don't know why I put in that little line. Let me get rid of that. Okay, so I'm going to move 1, 2, 3, 4 places. So I need a 1 with 4 zeros, which gives me 10,000 decigrams for every 1 kilogram. All right. Okay, let's do volume. Volume, by definition, is the space that matter occupies. Okay, for volume, we are either going to use liters. Okay, you will use this when you're using a beaker or graduated cylinder. Those are both lab instruments that measure in liters or milliliters, depending on the size. Okay, and then you can also measure volume in some unit cubed. And the reason for that comes from your math class. If you remember, volume is equal to length times width times height. And so right here, if you had centimeters long, centimeters wide, centimeters high, when you multiply all 3 of those, you would end up with centimeter times centimeter times centimeter, which gives you centimeter cubed. So we will use this unit when you're measuring something with a ruler. All right. Now, it's important to know that 1 milliliter is the exact same thing as 1 centimeter cubed. What I mean by that, okay, let's say I have a cubic object and each side is 1 centimeter. So this is 1, and this back here is 1. So we're going to call this, say, 1 long, 1 high, and 1 wide. And let's say we're dealing with 1 centimeter for each of those sides. So length times width times height, giving me the volume of the object, would be 1 times 1 times 1. So what I would end up having a volume of 1 centimeter cubed for this specific object. If I was to take that object and I was to drop it down into a graduated cylinder. Okay, so please listen carefully here. This is a technique called volume displacement. Volume displacement. If instead of using a ruler to measure this cubic object, if I did not have a ruler available, and instead I only had a water source available, this is how I would solve that. I would put some water in my beaker or my graduated cylinder. Let's say I just happen to use 10 milliliters, fill the graduated cylinder to 10 milliliters, okay? I would then take this object and drop it down into the water. When I put that cubic object, or whatever the shape is, down into the water, the object is going to displace, meaning move the water. You know that if you get into a bathtub full of water, the volume of water goes up because you now take up space as well. So you're going to see the volume of water rise when you do this. In this case, it would rise to 1 milliliter. The way you get the volume of the object is to subtract these two numbers. The change that occurred in the volume of the water is due to the object that you put in. So 11 minus 10 would give you 1 milliliter. All right, so volume displacement is a technique where you drop an object into water, a known amount of water, and you see how much the volume changes. The change in the volume of the water is the volume of the object that you've dropped in. Now I want you to notice it's the exact same object. So my volume right here is the same as the volume that I got up here from multiplying the length times the width times the height. And so because of that, over here, 1 milliliter is the same thing as 1 centimeter cubed. Okay, make sure you're comfortable with that and you know that for our quizzes and our tests. So when we're converting these, we're still going to use our King Henry died by drinking chocolate milk. We've got milli and liter. Liter is part of your base. Milli is over here. The liter is furthest to the left-hand side of your King Henry died by drinking chocolate milk, so I put a 1 there. I move 1, 2, 3 places. So I need 1, 2, 3 zeros. So for every 1,000 milliliters, there's 1 liter. Let's do the same thing with centiliters. King Henry died by drinking chocolate milk. I've got centi, which is right up here, and I've got milli, which is right here. And now I'm just using liter instead of gram or meter, centiliter instead of centigram or centimeter, because these were measuring volume. Centi is furthest to the left, so you need a 1 there. You move 1 place between the centi and the milli, so there are 10 milliliters for every 1 centiliter. All right, for this next one, I've got a milliliter, and I'm asking you to change that into centimeters cubed. So what I'm asking you to do right here is remember that 1 milliliter is equal to 1 centimeter cubed. Okay, we're going to apply that same information down here for our last example. I'm going to go back and redraw my King Henry died by drinking chocolate milk. I've got liter, which is part of my base, and then centimeters cubed. Okay, I don't see centimeters cubed up here. Okay? So what I'm going to have to do is I'm going to have to remember that 1 centimeter cubed is the same as a milliliter. So I'm asked in this example to convert from liters, my base, to milli, not centi. Anytime you see this little cubed, you're going to have to be careful. Cross that whole thing off and change it, rewrite it as milliliters. Okay, and then the problem becomes easy. Your liter is furthest to the left-hand side of your King Henry died by drinking chocolate milk. That's part of your base. So I put a 1 there. I move 1, 2, 3 places. So I need 1, 2, 3. So 1 liter is 1,000 milliliter, which is the same as 1,000 centimeter cubed, which is what this question asked me for. Okay? All right, let's do just a tiny bit more practice for me. Temperature, we need to be able to convert between temperature and Celsius. I'm expecting you to know this equation right here. Okay, in the United States, we use Fahrenheit or Celsius. In the scientific community, we only use Kelvin. So we need to be able to convert between Kelvin and Celsius. Thermometers that you have in lab will be in Celsius. We need to convert those. This is going to be a simple algebra problem. So for this first example, I'm going to rewrite the algebraic equation that I've given you. Kelvin is equal to degrees Celsius plus 273. I'm going to now plug in the information that I know. I'm given degrees Celsius. So instead of the degree C, treat degree C almost like a variable, like x in an algebra equation. I'm going to plug in the 68 instead. So 68 plus your 273. Get out your calculators for me. Pause the video while you do that. And then plug in 68 plus your 273, or if you're good at math, you can do that in your head, and you're going to end up with 341. So my answer to this one is Kelvin is 341. Okay, let's do another example. I'm going to rewrite my algebraic equation. Kelvin is equal to degrees Celsius plus my 273. I don't know my Kelvin, that's what I'm looking for, that's my variable, so I leave it alone. My degrees Celsius is 23.9 plus 273. So Kelvin is equal to, plug into your calculator. And when I do that, I'm getting 296.9. Now in math class, you would probably stop, but I've already taught you how to round to the appropriate number of sig figs. So we're going to have to take this answer and check, do I have the correct number of sig figs? I want you to notice that we are adding. So your rules for adding and subtracting say when you get your final answer, you need to look at your original numbers and look past the decimal. How many sig figs do you have past the decimal for each of the numbers you used? This one would be 1, this one would be 0. You're going to round your final answer so you have the least of those past the decimal when you add and subtract. So that means I can't have anything past the decimal. So I've got to get rid of this 9. Since the 9 is 5 or greater, that's going to cause the 6 to round up when I drop the 9. So my final answer is going to be 297. Okay? All right, let's work a couple the other way so that make sure you understand the algebra. So if I look right up here, I'm going to rewrite my equation. Kelvin is equal to degrees Celsius plus 273. In this case, I know Kelvin, so I'm going to plug the 418 in instead of the K. I'm looking for degrees Celsius, so that's my variable in my equation. That's like my x. Okay, so right now I need to solve for my degrees C. That's my variable. To do that, I need to get rid of the 273. I'm currently adding, so to get rid of it, I will do the opposite, meaning I will subtract 273 from both sides. So I'm just going to rewrite this in case you like doing that in your math class. You do not have to rewrite for me, but this is going to be 418 minus 273 is equal to the degrees Celsius. And now you're ready to just plug into your calculator. And when you do that, you should get 145 as your final answer is equal to degree C. Okay? I'm going to check my sig figs. Nothing past the decimal here, nothing past the decimal here, so I shouldn't have anything past the decimal here, so I'm good with sig figs. Let's do another example of that type. Kelvin is equal to degrees Celsius plus 273. For this last example, I know my Kelvin, so I'm going to plug in the 82. I don't know degrees Celsius. That's what I'm trying to find. So that's my variable in the equation. To solve for degree C, I need to get it by itself, which means I need to get rid of the 273. Right now I'm adding 273, so to get rid of it, I'm going to subtract 273 from both sides. So 82 minus 273 is going to give me my answer for degrees Celsius. When you plug that into your calculator, you should be getting negative 191 is equal to your degree C. So your Celsius temperature can be negative, okay? When I was growing up, my father was in the military, he was in the Army, and we've lived all over the world. I got to live in Germany, got to live up north in Maryland, got to live in Kansas, and in all of those places, especially Germany and Maryland, we had really cold winters. Those of you who have ever lived up north, our winters here are nothing compared to up north, but it was typical during the winter to have temperatures in the negative 10, negative 15. That was just common in the winter. So you might not be used to seeing negative degrees Celsius here, but it is common in other parts of the United States and the world. Okay, ladies and gentlemen, I'd like to show you one other type of problem before I let you do independent practice, okay? So let's say I give you a number, let's say 34.91 centimeters. And for some reason in a problem, you have to change that to meters. Remember that lowercase m stands for meter. So what I want you to do is think through, or you can actually write out your King Henry died by, oops, sorry, I forgot my by. King Henry died by drinking chocolate milk. I want you to focus on the two units that you're given up here in the problem, centi and meter. So I've got centi, meter, remember, is part of my base. And now I want you to look at the number that's given, find your decimal in the number that's given, and I want you to put your finger down here or a pencil on the unit that goes with that number. So in this case, I'm focused on the centi. To go from centi to meter up here, I'm going to have to move 2 places to the left, which means to convert centimeters to meters, I'm going to move my decimal 2 places to the left. So my decimal would move right here. So 34.91 centimeters is equal to 0.349 meters. Now, I put this little 0 right here at the front just so you can see my decimal a little better. You do not have to write that. So you can write your answer as just 0.349 if you prefer. That's perfectly acceptable. Let's do just a few other examples to make sure you understand. Okay, let's say I had some measurement. Say I gave you 0.0438 kilograms, and I need you to convert that into grams. Think through your King Henry died by drinking chocolate milk. Focus on the unit that you're given in the problem that goes with the number and the unit that you're asked to convert it to. In this case, I've got kilogram and gram. I'm going to start on the unit that's given with the number. So I'm going to start in this case on kili, and I'm going to move my finger or my pencil to the unit that I'm asked for. So if you looked, I moved 1, 2, 3 places to the right. So up here, I'm going to move my decimal 1, 2, 3 places to the right. So this is going to be equal to 43.8 grams. So the 0.0438 kilograms is the same as 43.8 grams. Okay, I'm going to show you one more example just in case you need it. If you're feeling comfortable and you remember this from probably middle school or math class, then you are welcome to stop the video at this point and go directly to independent practice. But if you're feeling iffy still, I'll go through another example with you. So let's say I go back into lab and I have a measuring instrument that measures in liters, and it gives me a recording of 10.4 liters. And for some reason, I need to convert that into milliliters. So I'm going to think through. My King Henry died by drinking chocolate milk. I'm focusing on the units that are given in the problem. Liter is part of my base. Remember, your base is gram, liter, and meter. Milli, right here from milliliters. Okay. I'm going to focus on where the decimal is right here, starting with my pen or my finger on the unit that goes with the number. I'm going to move from liter to milli, 1, 2, 3 places to the right. So I'm going to have to move this 1, 2, 3 places to the right. I'm going to fill in zeros right here for placeholders. So that would be 10400, which is 10,400. If you want to put the comma, you don't have to have it. And you can put the decimal, but you certainly don't have to if you don't want to. So for this one, your original 10.4 liters is equal to 10,400 milliliters. Okay, if you have any questions or if you need extra help on anything before you start the practice on Google Classroom, feel free to reach out to me. Ladies and gentlemen, make sure you do the practice and make sure you check your answers as well. Good job, guys.